Ladies and gentlemen, the opening ceremony is going to start in a minute. Please find and ready your comfortable place. Excellencies, distinguished guests, participants, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Good morning, selamat pagi, peace be upon you. Best wishes to all of us. We thank God Almighty because the blessings and graces we can meet and join at this virtual conference. Ladies and gentlemen, we are delighted to welcome you to the 12th International Conference on Global Research Conversation, ICGRC 2021, with them challenges, opportunities, and innovation in global conservation during and the post-pandemic COVID-19. First of all, it is my pleasure to be the master of ceremony for the 12th ICGRC. My name is Hebi Luxiova, student of biology undergraduate study program. It is my pleasure to welcome you here this morning. Warm regards and greeting from me. Before we begin this event, first let us pray that God will make the event that we will hold today go well and get God's blessings. We can start together with the words of prayer. Bismillahirrahmanirrahim. Hosted in the city of Paris, Manis, Java, Malang, Biology Department, Faculty of Mathematics and Natural Sciences, Brawijaya University, has the honor to present you this international conference. This conference is annual conference since 2010. The conference aims to strengthen coherence and synergies among several areas, including agriculture biodiversity, conservation ecology, environmental science, and sustainable materials and resources. The 12th ICGRC facilitates the international community to synergize their latest knowledge and discoveries to identify fundamental problems and cope with achieving sustainable biodiversity and new strategies in order to prevent the decline of global biodiversity. It is an honor to me to introduce and welcome the keynote speakers, the Honorable Associate Professor Dr. Saiful Arif Abdullah from University Kebangsaan Malaysia, the Honorable Professor Dr. Catur Retnaningdia from Universitas Brawijaya, the Honorable Professor Mary Barton from University of South Australia, the Honorable Associate Professor Chairat Trisabsanton from King Mongkut University of Technology, Thonburi, Thailand. And also, we welcome all the presenter and participant of the 12th ICGRC 2021. Ladies and gentlemen, we are now opening the ceremony of ICGRC 2021. First, we will sing the national anthem, Indonesia Raya. The audience, please stand up. The audience may have a seat. All right, we are going to the next agenda. We are now going to listen to the welcome speech and implementation report delivered by the Chairman Committee of ICGRC 2021. Please welcome Mr. Nia Kurniawan, Doctor of Science. Time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen, and our honored guests, Professor Dr. Saiful Arif Abdullah, Professor Mari Barton, Professor Chairat Center, Dr. Arnold Satsangyan, and Mr. Romualdus Nugraha Catur Utomo. With our great pleasure, we would like to welcome all scientists, professionals, and lecturers who have interest to the existing field in global resource conservation to attend our 12th International Conference on Global Resource Conservation on November 13, 2021. Substantively, the conference principle is aimed to share up-to-date issues in challenge, opportunities, and innovation global conservation during and post-pandemic COVID-19. In many developing countries where rapid development threat to recovering post-pandemic, such as issues is significantly crucial. We hope this conference will be an exciting and productive gathering of people with similar interests to share their knowledge, experience, and seek stronger network each other. Today, we have more than 80 participants from all around Indonesia and from several countries. We deeply thanks to anyone in these industries for their dedication and support to make this conference a successful one, and we would like to encourage all of you to put a continuous interest and involving in the next year's conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Mr. Nia Kurniawan, Doctor of Science, for speech and officiating for ICGRC. Next one, welcome speech delivered by the Dean of Faculty of Mathematics and Natural Sciences, Brawijaya University. Please welcome Professor Widodo PhD, Medical of Science. Time is yours.
Thank you, MC, for the times. Assalamualaikum warahmatullahi wabarakatuh. First, let us express our gratitude to the merciful God who has granted us with blessing and grace that we could gather here today to attend the International Conference on Global Resource Conservation. Ladies and gentlemen, respectable keynote speaker, presenters, and community, I am pleased to welcome you to the 12th International Conference on Global Resource Conservation 2021, and the topic, Challenges, Opportunities, and Innovation in the Global Conservation during and post-pandemic COVID-19. And this conference is really important in anticipate the pandemic effects on the global conservations, and hopefully this event will facilitate the international communities to synergize and disseminate their latest knowledge and discoveries to create opportunities and innovation in overcoming global conservation challenges caused by the COVID-19 pandemic. We are also convinced that the role of science, technology, and culture approach to the society is important in saving biodiversity for our future generations. And therefore, with the galaxy of reputed speakers today, this meeting also may provide opportunities for developing collaborations among participants of this conference. Distinguished guests, ladies and gentlemen, furthermore, I would like to express my sincere gratitude to speakers who join us to share their knowledge and expertise, especially to Professor Saiful Arif Abdullah. Thank you, Prof, from University of Kebangsaan Malaysia. Also, Professor Chairat from the King Mongkut University of Technology, Thonburi, Thailand. Professor Mary Bartons from University of South Australia. Professor Chatur and Professor Amin, of course, from Brawijaya University. Also, I think there is Dr. Arnons and also Dr. Chatur Nugraha Chatur Utama, from Germany. Thank you for the participants and share your knowledge in the conference. And also, I would like to give my most profound appreciation to head of biology departments and committee, MC, moderators, presenters, and conference participants from across the country. I hope this conference is really fruitful and important to solve any case of the conservations. And finally, in anticipation of the fruitfuls and meaningfuls of the conference, I am, as Dean, Faculty Mathematics and Natural Sciences, officially open the 12th International Conference on Global Resource Conservation 2021. We wish you most fruitful days of interesting and enjoyable conference. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Professor Widodo, PhD, Medical of Science, for the remarkable speech. Excellencies, distinguished guests, ladies and gentlemen, this is the end of the opening ceremony. We are now continuing our meeting to the next agenda, that is plenary session, which there are two sessions. Ladies and gentlemen, please join me in welcoming keynote speakers, Associate Professor Dr. Saiful Arif Abdullah from University Kebangsaan Malaysia and Professor Dr. Chatur Retnaningdia from Universitas Brawijaya. The keynote speech will be moderated by Mrs. Vicky Vidayanti, Master of Science. To Mrs. Vicky, time is yours.
Thank you for the MC. Now, before we begin the plenary session, let me give you some information. The first keynote speaker is Associate Professor Dr. Saiful Arif Abdullah from University Kebangsaan Malaysia. And the second keynote speaker is Professor Dr. Chatur Retnaningdia from Universitas Brawijaya Indonesia. Okay, before we begin the plenary session, let me give you the CV of our first keynote speaker. The first keynote speaker is Associate Professor Dr. Saiful Arif Abdullah from University Kebangsaan Malaysia, and this is his email address, saiful@ukm.edu.malaysia, and he's expert in landscape ecology, conservation planning, and wildlife ecology, and his recent publication is related to this major also. Okay, before we start the presentation, let me give you information. If you have any question, you can use chat box by writing your question in the chat box, or you can use raise hand menu in your profile. Okay, let's start the presentation. Associate Professor Dr. Saiful Arif Abdullah, time is yours. Do you need our help to share screen about your slide, sir? Dr. Saiful? Please mute your speaker, sir. Yes,
Hello?
we can hear. Yes, we can hear
Okay,
your voice.
right. Okay. Thank
It's
you.
okay.
Right. Just a bit technical, not problem, but a glitch. Yeah. Okay. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
Selamat pagi, salam sejahtera, and very good morning. Thank you to the moderator, Miss Wiki Widayanti, for the brief and short introduction for myself. First of all, before I begin my presentation, I would like to thank to the organizer, the Faculty of Mathematics and Natural Resources, Brawijaya University, for giving me this chances or opportunity, and I am feeling grateful and honored to be one of the plenary speakers in this conference. And special to Prof. Amin, because Prof. Amin unofficially invited me to be as a plenary session sometimes in October. Thank you, Prof. Amin, and also Dr. Nia, who always communicate with me to give me some information and others that related to this conference. So based on the theme of this conference, which I think it is really relevant to this current situation. So the topic that I choose to share with you this morning is strengthening conservation planning at protected area during COVID pandemic era. So let me share my my slide. How to share or share screen. Okay. All right. Can everyone see my slide?
Yes, it's clear.
Okay, thank you very much. So again, this is the title of my presentation, Strengthening Conservation Planning at Protected Area During a COVID Pandemic Era. So when Dr. Amin asked me to give this talk based on the theme, so a bit challenging for me to make decision or to decide what title that should I present in this conference. Should be in line with the themes of the conference. So this is the title. Alhamdulillah. So for the first slide, so I begin with what is protected area, right? So this is the definition given or provided by WCPA, or World Conservation of Protected Area, IUCN, International Union for Conservation of Nature, where protected area is an area of land and sea, especially dedicated to the protection and maintenance of biological diversity and of natural and associated cultural resources, and managed through legal or other effective means. So this is the official definition that has been adopted or used by countries that have protected areas. And at this time, most countries do not have their own definition of protected areas. So the definition by the IUCN is used as a base or guidelines for them to manage their protected area. Okay, this is the IUCN protected area management category, which established since 1994. It has 6 categories. One divide to 2, 1A and 1B, 2, 3, 4, 5, and 6. And each category has its own definition. So for countries that have protected area, this category is used for managing the protected area of each country. Right? So as we can see in the definition, generally the core or center of protected area is conserving biodiversity. So this is the core or the main role played by protected areas. So the core is biodiversity conservation, but it's not only about biodiversity, but also it consider other aspects such as marine ecosystem, the cultural that has in the protected area, the unique landscape, so like biocultural landscape, cultural landscape, and so forth, and also the natural monument. Right? So why biodiversity conservation is very important? So as we can see in this figure, show the Living Planet Index or LPI, which measure the abundance of mammals, birds, fish, reptiles, and amphibians across the globe, right, or around the world. We can see here that based on this data from the 1970 to 2016, the vertebrate population sizes dropped by 68%, but there are difference between each region. Yeah? So we can see here that the Latin America and Caribbean, the drop of the LPI is very huge here, yeah, about 94%, yeah, followed by Africa, Asia, North America, and Europe. So this is why biodiversity conservation is very important. It's very, very critical issues right now, the loss of our biodiversity. Right, in terms of the, this figure show the planetary boundary, which has been developed by scientists from the Stockholm Resilience Centers based in Sweden. So they measure several parameters which include the biosphere integrity, which is related to biodiversity and ecosystem. Right? So it divided based on this planetary boundary. They divide into 3 zones, what we call it as a below boundary, which is the safe zone, the yellow, the green color, right? And then in zone of uncertainty, which is the increasing of risk, yeah, in yellow color, and the orange color is beyond zone of uncertainty, which is the very high risk zone. Yeah, so we can see here from this figure the biosphere integrity, which represent the biodiversity or the ecosystem is already beyond or now in the zone of uncertainty. So we can see that the critical issues of biodiversity. So the other parameters like biogeochemical flows, which contain phosphorus and nitrogen, also face the same problem. And climate change also. Yeah? Now we are talking about the climate change is one of the global environmental issues. Yeah. And then here is some data about the threatened species listed by IUCN Red List. We can see here that from this data, more than 37,400 species are threatened with extinction. Right? You can see that the mammals about 26%, shark and rays about 36%, amphibian 41%, which is considered very high proportion. Yeah. So, but this is still 28% of all assessed species, only 28%. Right? We can see that how our biodiversity in the very critical situation. Right? So, as response to the issues, we know that many countries around the world they develop protected area. This protected area considered as a long time approaches used by many countries to protect not only biodiversity but other natural resources. And biodiversity is also one of the main or major aspects that considered in the IG target 2020. Yeah? It falls under IG target 11, where the number 11 IG target is very related to the strategic goal C. Yeah? IG target has a 5 strategic goal, and the strategic goal C is very related to the protected area, which is to improve the status of biodiversity by safeguarding ecosystem, species, and genetic diversity. Yeah? So the target by 2020, but now we are already in the 2021, terrestrial ecosystem supposed to be 70% of the total land cover, and marine ecosystem supposed to be 10% to be protected by 2020. But what we have now is the current information or the current data shows that the percent of terrestrial covered within the protected area system is 16.64. Yeah, only a few percentage left to be achieved, the 17%. Yeah, but now we are already in the 2021. But for the marine ecosystem, it achieved on until this day only 7.74%. Yeah. So other than the protected area, now we have what we call as a IUCN Green List of protected and conserved area, which is some kind of a bit higher the level compared to the common or normal protected area. So this is something new in terms of the or to enhance the conservation of biodiversity. Yeah? So this area is considered as a site certified as being effectively managed and fairly governed with long-term positive impact on people and nature. So this area will be evaluated every 5 years. Has a set of criteria which include the quality of protection of natural values and the effectiveness of action against threat. So this is the things that the main criteria that they use to evaluate the area to be qualified as the IUCN Green List. Yeah. So to date, we have around the world or the globe, we have a total of 59 sites from 16 countries. Yeah. Even Malaysia also has what we call it the to be. They list about 5 protected area as to be nominated as IUCN Green List. Yeah. So, however, protected area also threatened by land use development. Yeah, not only the common forested area, but the protected area also face the same problem. Yeah, we can see here that this is the trait, yeah, that affect the forested and protected area, which include the indirect threats, which is population growth, economic growth, policy development, which will be affect or triggered other what we call it as the external direct threats and also internal direct threats. Yeah, so external direct threats, for example, logging, urbanization, commercial agriculture, land use change, pollution, and so forth. Yeah, while internal direct threats, for example, overhunting, exploitation of valuable plants or animal, illegal encroachment, and forest fire. So all these factors affected or give a threat to the protected area. Right. So this figure show the trend of the primary forest and tree cover for several regions: Amazon, Congo, tropical Sunderland, Guinea in West Africa. We can see that the proportion is not so impressive. Yeah, the primary forests are getting less and less, and the tree cover. The tree cover not only forest area but also covered the plantation area. Maybe, for example, the rubber plantation or another green area. So they call it as tree cover. Yeah. So the proportion is not so very impressive. You can see that the declination trend in several period of time in all regions. Right. In terms of the connection, yeah, or the connectivity of protected area, studies by Ward in 2020 showed that around the world, only 9.7% of the protected area is connected. Yeah, only 9.7%. Yeah, from figure here, we can see that the Greenland, Finland, Egypt, Guyana, Congo, and Papua New Guinea is some example given by this paper. Yeah, you can see that the blue one is protected area, the light, the yellow light or green color is non-intact land, and the green one is intact land. You can see that the protected area is getting become less connected with other forested area. It become isolated, yeah, or fragmented. So this is the proportion of disconnected and connected protected area for each region and for each country. We can see that in most of them in all region, yeah, almost all region, the protected areas are not connected. Yeah, very few. Yeah, especially in the Asia and the Africa countries. Yeah, very few protected area are connected with other forest area. Yeah, right. Deforestation, fragmentation, and disconnected of protected area can cause or trigger other issues. And one of the most prominent is a conflict between human and wildlife. Yeah, because once you open the forest, it will the accessibility is getting easy. Yeah, so the poachers easily intrude to the protected area, and then wildlife also lost their habitat, and they intrude to the settlement that will cause human and wildlife conflicts. Yeah. So this is some data provided by Torres. The cause of when the wildlife intrude to the settlement, so they may it may cause the predation of the domestic animals, the damage of crops, and also the attacks to human that cause life. So we can see that the damage to crop is very high, especially by mammals compared to birds and reptiles. Right. So wildlife trade. This is another issue that when poaching is is getting higher and higher, and then people bring out the animals and they will trade, yeah, to make business, selling all the animals like birds, reptiles, mammals to other country and also to other internal market. We can see that from the figure at the right side, the species or the vertebrate with a threatened status, vulnerable, endangered, critical, endangered, also having this problem. They are traded, yeah, throughout the world. We can see that the proportion of the vulnerable species is very high. About 30 is the highest, which is 34.6%. Yeah. So another thing is wildlife trafficking. This is the issue. Yeah? People illegally, yeah, smuggling the animals outside the country and selling. We can see that the proportion of illegal wildlife trafficking is getting higher and higher from 1975 to 2010. Right, here show some trends how the black rhinoceros experienced a very dramatic loss. Yeah? From the 1970s to 2010, we can see that it's a drop very, very sharply. And the left figure show how the route, yeah, the smuggling or the trafficking of the rhinoceros horn to other country, to Western Asia, and also to the East Asia, and also to the Southeast Asia. Right. Because of the deforestation, loss of connectivity, fragmentation, it will give a threat to the protected area and also trigger the illegal hunting or poaching, and also wildlife, human-wildlife conflict. We can see the relationship, and then it will bring to the issues of the wildlife trafficking and wildlife trade, which is give exposure to human. Yeah, how the animal exposed or to the human. Yeah, so animal and human is getting close. Yeah, getting close, and at one time they are close interaction between human and animal. So because of this, it have the zoonosis. The zoonosis process will be happen, which is the transmission of the diseases from the animal to the human, right? And it will cause the outbreak. Yeah, for example, here the Ebola, anthrax, Japanese encephalitis, rabies, and West Nile, and the most recent everyone knows that, which is COVID-19. Yeah, so many scientists or people believe that this virus is come from the animal. So some people said come from snake. Some said that it comes from bats. Yeah, so not sure about which animal it come from, but this is what happened now. So this is how this figure show the interrelationship, how we getting close to the animal that cause the transmission of the diseases from wildlife to human that cause the outbreak. Right. So at this time, what we can do is we have to, in the context of that related to biodiversity, so we have to reduce the interaction between animal and human. So this is where the protected area can play its role to be as one of the element to mitigate the outbreak. Yeah? Because protected area is something, the area we conserve or we gazetted under several legislation or laws, yeah, compared to other forests. For example, in the context of Peninsula Malaysia, the forest reserve is a forest, but still subject to development. But protected area is a conserved area. So this is the I think it's very important we sustain the protected area, because now protected area itself is threatened by land use development, right? So now, during this COVID-19 pandemic era, the role of protected area is not only about biodiversity conservation, but now it expanded to be as one of the key or the main element to mitigate the outbreak of the COVID-19 pandemic. So what we should do now, we have to strengthen the conservation planning at the protected area. So what we need, and why, what we need to strengthen the protected area and why. Yeah. So I outlined 5 things here. So the first one is a land use and land cover modeling. Yeah. So we have to have the present and the past land use, which is we can do some analysis, analysis to predict of the future land use land cover. Yeah. So from here we can do some comparison, or we visualize the impact of land use development at the protected area, but not only at the protected area, but also the important is the surrounding of the protected area. Also important to be conserved, right? But the issues is the forest area or area outside protected area is subject to development. So this is the challenging for many land use planners, right? So this is some example part of my studies to do some land use modeling. Yeah, we have the past and present land use, and then we do some analysis at the process, which include identification of the driving forces, change analysis, transition potential, change prediction, and model validation, and we predict the scenario of land use in the 2028. This is one of the biosphere reserve in Peninsular Malaysia. No, not biosphere reserve, but Ramsar sites in Peninsular Malaysia. Yeah, we can predict, we can visualize what happened to the land use development to this area. Now here we can see the changes of land use. If we retain the current scenario, so it will be happen. So this is very important. If we retain, so this will be happen, but we have to do something to make it less impact in that particular area, right? So why we need this land use land cover modeling? The first one, we can identify the factors, whether there is a socio-economic or physical factors that drive the changes at the protected area, because different protected area maybe has a different factor that affect the changes. Yeah. So the second one, we can use to evaluate the success and or the failure of the existing conservation planning. Yeah. Conservation planning meaning that the process of locating, configuring, implementing, and maintaining. Yeah. And from here, we can also identify the priority aspect to improve conservation planning, right? And of course, we can visualize and compare the impact of land use, and also can be used in designing protected area, the future protected area or the new protected area in terms of the location, elevation, and so forth. The second one, what we need is the management category framework for protected area, right? So right now, as I mentioned before, we only depends on the category provided by IUCN, but we have to understand that every country or every area has their own environment, culture, social, and economic, different from one place to another place. So meaning that we have to put the management category in the local context. So with that, we develop a framework how to decide which protected area fall in which group. Yeah, but still we use the category of IUCN as a base, but in terms of the criteria or sub-criteria for each we have three subcategory which environment, four: environment, economy, social, and management. So each of them has the criteria, and the criteria for each category is different. Yeah, the process which will be is determined by a survey. Through survey, we ask the management of the protected area, the visitors, and the community. So we identify which criteria for each category, right? So after that, we do the assessment if the criteria is met, is fall in that particular category. So this is the example how we identify the suitable category or protected area management category for each protected area in 15 protected area in Peninsular Malaysia. This is based on my students' studies, right? So this is the result from the assessment. So the 15 area, and then this is the comparison. Yeah, comparison between the management category, the present we use based on IUCN on the left column, and then the right side is from the framework. So we can see that some changes here. Yeah, for example, the Sungkai Wildlife, K is supposed to be from 1A. Yeah, they use 1A, but based on our assessment, or when we use the criteria in the local context, it falls under 1B. Under 1B, same goes to the Tioman Island Wildlife Reserve from 1A to 1B. Also, the Crown Wildlife Reserve also from 1A to 1B, and Paya Indah, they at the beginning, now they it not fall any category, but based on our assessment, it falls under the category number 5. So this is the way how we decide the management category for each protected area, right? So why we need it? Yeah. So it's very important.
Dr. Saiful.
Yes.
The time is like now 5 minutes later.
Okay, I will move fast.
Okay, thank
what
you.
we need is finding the right management category for each protected area. The second one, we can develop the proper management plan. Yeah, there is the strategies and action plan are developed accordingly and in the right context. And the third one is sustainability assessment can be conducted according to the management category. So the third one is conservation status of protected area. Yeah. So conservation status is an estimate of the present and future capacity of a protected area to maintain ecological integrity, resilience, and adaptability to environmental change on a local, national, and regional scales. Yeah, but we know that before this, we have the conservation status at the species level, ecosystem level, but now we have analysis of conservation status at the landscape level. So this is the level that we have to use now. Yeah, to introduce in terms to evaluate the conservation status of protected area, but we must consider both the inside and outside of the protected area. So this is some of the measurement that we measure. First one, before we determine the conservation status, we have to evaluate the conservation value. We use 3 parameters here: naturalness, fragmentation, and connectivity. This is all the landscape level analysis. Yeah. So we combine the inside and outside conservation status to determine the overall conservation status of the particular protected area. So this is the example. Yeah. So it has the category, yeah, conservation status: very critical, critical, moderate, good, and very good. Yeah. So this is the result we got from this analysis. Yeah, for crowd overall 2014 is good, but when we do the based on the land use modeling, it become moderate. For Tasik Bera, Ramsar site critical, 2028 also critical. So this is the things that we have to know to improve the conservation planning of the protected area. So this is what we need, why we need. So the first one, to provide a quick information on the ecological capacity of protected area and helping managers identifying high priority protected area for improving ecological capacity, right? And then identifying landscape ecological parameters that need attention by managers and can be used as one of the components to measure conservation effectiveness. The fourth one is conservation effectiveness, right? So this is we measure on how well the effects in safeguarding good conservation status, in maintaining biodiversity and ecological integrity, abating threats, has educate and appropriate resourcing and management processes for long-term conservation and persistence of nature and its associated ecosystem services and cultural values. Yeah? So at present, we only measure the management effectiveness, yeah, but not conservation effectiveness. Yeah. So in terms of the sustainability context, need the wider perspective, which include not only management aspects, but also we have to consider the ecological and socio-economic aspects. So this is how we measure the conservation effectiveness. Yeah, we have the component design, ecological integrity, and management. It has its own sub-indicators, and this is the indices we use to measure. So this is the process how we determine the conservation status of the protected area. Yeah, there are so many processes here from the data normalization to the validation. So this is the result we get, yeah, for each protected area. Yeah, for example, the Klang Gate is very poor, Bukit Kutu is very good, Sungai Dusun is good, and overall for the three, we get at the average in that particular area in Selangor State, in Peninsular Malaysia, is fair. So this is the category of the effectiveness category: very poor, poor, fair, good, and excellent. So why we need, again, yeah, we have to can provide a quick information, yeah, on the level of the conservation effectiveness of protected areas, and again it will help the managers in identifying high priority area component for improvement, and also identifying parameters for each component that need urgent attention and solution by the managers, and can be used as a baseline in formulating policy related to natural resources, conservation, and protection. And the last one is the ecological network system, yeah, so which is a system that connects patches of natural forests to assist wildlife movement, and it contains two, whether there is a structural or functional connectivity, and it involves both natural and also the semi-natural ecosystem, which is the agricultural area. Yeah, so some patches can be act as a stepping stones, and to build the connectivity, usually we use keystone species as a base to develop the an ecological network system. So this is the example of the ecological network system, which contain the buffer zone, landscape corridor, core area, stepping stones, and also the linear corridor. Yeah? So this is the effort taken by our government to enhance connectivity throughout Peninsular Malaysia. Right? We call it the central forest spine. Yeah, some area is already in fragmented form, so they are working to identify the suitable area to be develop connectivity. Some area is already has the corridor, yeah, the structural corridor to connect between patches. Yeah, so why we need this is, of course, we need to improve the connectivity for wildlife movement. Yeah, and then another important point is to reduce the interaction between human and wildlife. This is related to human-wildlife conflict and also the wildlife trade and others. Yeah, and then again, yeah, it's very important to improve or increase the ecological capacity of the protected area and also at its surrounding area, and can be used as a base baseline in formulating policy that related to land use planning. So all these five things are interrelated to each other. They are not standalone, which is very important for us to consider or to be used to improve, or we have to strengthen the conservation planning at the protected area. Right? So I come to the conclusion that the first one in the pandemic era, so what we need is we have to reduce the interaction between human and wildlife. And here protected area can play a very significant role to reduce the interaction. So and then what we need is to ensure that this can be achieved. So we have to strengthen the conservation planning at the protected area, as I outlined in this presentation. So what I can say that we have to from nature, which is the outbreak. Outbreak is a belief that come from nature, is from animal. Because mammals usually is a host for many viruses. So we have to back to nature. Back to nature meaning that the role of the protected area in this context, conserved area, to mitigate this outbreak. So from nature back to nature. So but anyway, the commitment and support by related stakeholders, policymakers, the politician is very, very necessary. If not, it's very difficult for us to achieve all what we have in our mind, right? So that's all. Thank you very much.
Thank you, Associate Professor Dr. Saiful, for the very interesting presentation. But before we start the discussion, we should know the another presentation for the next keynote speaker, that is Professor Dr. Chatur Ratna Ningdia. Professor Chatur, are you ready? Do you need any help?
Yes, I am ready.
Yes, thank you. Before Professor Chatur starts the presentation, let me give you some information about Professor Chatur. Professor Dr. Chatur Ratna Ningdia from Brawijaya University, Indonesia. She is expert in aquatic ecology, and the publication is related to the aquatic ecology that you can see in here. There is several publications in 2021. Okay, that is a short introduction for Professor Dr. Chatur. Professor, time is yours to present your presentation.
Okay, thank you very much. I will start my share screen. Is anyone can see my slide?
Yes, of course.
Yes, okay. Good morning, ladies and gentlemen. Assalamualaikum warahmatullahi wabarakatuh. Selamat pagi. The Honorable Dean of the Faculty of Mathematics and Natural Sciences, Universitas Brawijaya, and the Honorable Associate Professor Saiful Arif Abdullah, Professor Mary Barton, and Associate Professor Chairat, and also other speakers at 2020 ICGRC event. and the ICGRC committee. Today, I will talk about evaluation of the water quality of aquatic ecosystem and how can we do it during this pandemic. Yes, the water resources available on Earth are mostly available as a sea water, and only a small part is in the form of fresh water. However, this fresh water is very much needed for human life and other living things. But today, we are facing a global problem related to water resources in the world, that are water quantity and water quality. The first global problem is water quantity. Environment degradation and increasing the human population have an impact on decreasing water quantity, resulting in water scarcity in some areas. This scarcity also happen in Indonesia, such as in the Gunung Kidul, Yogyakarta. And the available of clean water is greatly reduced, and in general water is being waste because of human activity. There are kind of human population growth pattern. This is high, medium, and low variant. This will have an impact on difference in the number of human population on Earth. And water scarcity occurs in several countries that have very high human population growth. This is an estimate of the addition of water scarcity that occurs every 25 years. In years 2050, water scarcity saw almost 3 times compared to 2000 year. And the second of the problem of global water problem is water quality. This problem can be happen because some human activity such as industry, settlement, recreation, agricultural, animal husbandry, fishery cause water pollution. This unsafe water will further have an impact on increasing disease in human. In the context of conserving water resources, it is necessary to evaluate water quality in several aquatic ecosystem periodically, which generally we use physical and chemical parameter for evaluating the water quality. However, nowadays many researchers have developing a method for evaluating biological water quality using bioindicator. Some of the advantages how we use a biological method for evaluating water quality is that they are low cost and easy to do, provide information about combined effect, and able to detect the presence of micropollutant in the environment. And then this is in contrast with the monitoring water quality physical and chemically. If we use physical chemical to evaluate the water quality, it's very expensive and only describe the condition of the environment for a moment. So how evaluation of water quality in this pandemic, how we can do it? We can see that during this COVID-19 pandemic, human mobility and laboratory capacity is limited. Therefore, an easy and inexpensive method of evaluating water quality is needed. So everyone can do how the biomonitoring using biology. Monitoring water quality can be used. We can use bioindicator or biomonitoring. Now is the most appropriate method today. In this paper, I will describe how the role of biomonitoring assessment of water quality and some example of its application, especially how to use benthic macroinvertebrate and periphyton or attached plankton as bioindicator of water pollution. Benthic macroinvertebrate is organism that live in the bottom substrate and have large enough to be seen directly with the eye or only using loop. Why this benthic macroinvertebrate can be used as biomonitoring of water quality? It is because he cannot escape from pollution, can show the cumulative impact of pollution and habitat loss, and affected by physicochemical and biological condition of a stream. This is an example of some benthic macroinvertebrate we can found in water ecosystem. This is included some gastropod. This is in the some gastropod, and then annelide, Hirudinea, this is Hirudinea, and some larvae or of Diptera, Odonata, Coleoptera, and Plecoptera. If we will use benthic macroinvertebrate to biomonitoring of water quality, there are some level that we can observe, such as organism level, population level, community level, and then ecosystem level. This level will determine what the parameter we can observe. And today I want to give an example how to use a community level to monitoring the water quality. In this community level, we can enumeration the taxarishness, density, diversity index, similarity index, biotic index, or combination of that. Three-step process. What we should pay attention is how we sampling of that organism, data compilation, and compare to reference site. Benthic sampling is very easy. Namely, we can use a serber net if the substrate is gravel or rocky, and Ekman graph if the bottom of water is muddy, and we can modify this tool according to our purpose of research. And after sampling, we then selected benthic macroinvertebrate and preserve them, and also we can count them. But sampling also can be done with semi-quantitatively by selected rock or wood or artificial substrate in the water. And for qualitative sampling, it can be done by hand picking from all available habitat at a certain time, as long as you have to get a penthouse at least 150 individual. This is a requirement to how to use a biomonitoring indicator to know how the quality of the water. From the enumeration of this benthic macroinvertebrate, we can then analyze the data using several index that have been developed by researchers such as taxa richness, number of EPT. EPT is Epimeroptera, Plecoptera, Trichoptera. This taxa indicating a good of water, and some other biotic index such as Heisenhoff biotic index, Chironomidae taxa, family biotic index, that is indicating organic pollution. Biotic index such as Heisenhoff biotic index can show the level of organic matter pollution in the water. A value close to 0 indicate that good water, because in this water many of benthic macroinvertebrate most sensitive for the pollution. And then while F value close to the 10, it's indicated that water is polluted. And can be known tolerance value of the benthic macroinvertebrate. This can be seen from other researchers that use tolerance value to know how the quality of the water. This is how we can calculate the Heisenhoff biotic index from the result of identify and enumeration of benthic. So from this value, so we can conclude that how the water quality is. In order to have an idea in how to do biomonitoring using benthic macroinvertebrate, I will give some example of my research. This is our study. I conducted quasi-experimental research to determine the success of phytoremediation by planting hydromacrophyte in artificial irrigation canal, and I monitor the success of phytoremediation using a benthic macroinvertebrate indicator. Phytoremediation, we modify the pitch of a channel, drainage channel, and then we planting with some of aquatic plant, hydromacrophyte, and then from artificial irrigation channel, we evaluate the water quality in the upstream, in the middle, and in the downstream. The increase of water quality can be seen from the increase of the Sennenweiner biotic index, Sennenweiner diversity index, taxa richness, evenness, and the decreasing of a dominant index, as well as decreasing the FPI value. We can see here that they are sorry, that they are decreasing water decreasing from pure to fairly poor, and from moderately polluted to lightly polluted here. So we can see here that planting of hydromacrophyte can increasing the water quality. It can be seen from the benthic macroinvertebrate as bioindicator. This can also be seen from the result of PCA analysis, which show that a significant change in the quality of the water in the downstream, here in the downstream, after undergoing the phytoremediation process. At this downstream location, pollutant level decreased both based on the physical and chemical quality of the water and the result of biomonitoring using a benthic macroinvertebrate, that is a family biotic index. Also, in the second study, I plan hydromacrophyte in situ in irrigation canal as riparian vegetation. And then I evaluate the success of phytoremediation with benthic macroinvertebrate as bioindicator. And the research setup is as follow. I evaluate water, physics, chemical, and biological in upstream before planting, and in the middle and in the downstream. This is the improvement of the irrigation water quality is reflected in change in the community structure of benthic macroinvertebrate, which previously this is dominated by Chironomidae, and then Melanoides tuberculata and Melanoides granivera in the upstream area, and replaced by pollutant-sensitive species. This is Paetidae and Caenidae. This Paetidae and Caenidae is indicator of a good water. This change was clearly seen at 4 days after planting of the hydromacrophyte. So the water quality we can evaluate with the benthic macroinvertebrate as water quality. And from value of some biotic index, this is Heisenhoff biotic index, we can see that planting of riparian vegetation capable to improve the water quality from significant organic pollution become a fairly significant organic pollution. And based on the sand and winter diversity index, can be concluded that the planting of riparian vegetation along 275 meters capable to improve the water quality from slightly contaminated to uncontaminated. That is an example about how we can evaluate the water quality with benthic macroinvertebrate. The second for biotic indicator is diatom or periphyton or periphyton. Here we can use to biomonitoring the water quality. Periphyton or attached benthic algae, a group of various organisms that grow or live on the free surface of objects that float and or sink in water, such as a plant, a wood, stone, and so on. This periphyton generally treated as benthic, but some organisms may be a part of the plankton. The advantages of use periphyton as an indicator contamination is due to their abundance, is easy to find, easy to collect, and easy to identify, and they have differently responses to various contaminants. One of the periphyton group often used as a bioindicator of water quality is the algae of diatom group. And we can use some biotic index to know how the quality of the water, such as a tropic diatom index, is indicated of the nutrient level in the water, and then percentage pollution tolerant value is indicated of organic pollution level in the water. This is some example of diatom that can be found in the water. Diatom analysis can also be done by placing an artificial substrate in an artificial ecosystem where we want to monitor the water quality. We can swap the diatom from the surface of the substrate, preserve them, and then observe in the microscope. In this study, I want to improve the quality of irrigation by carrying out continuous culture phytoremediation process in the pond. And the pond, they are three pond. We divided in the planting with several emergent, floating, and submerged hydromacrophyte. And phytoremediation success, we are monitor using diatom as bioindicator. And here, irrigation water flow is 0.3 liter per second. And then we evaluate the water it says in the inlet, and then in the pond 1, pond 2, pond 3, and pond 4 as an outlet. This slide shows how we prepare an artificial substrate of periphyton to be used for biomonitoring. Ceramic placed in pool water with the help of bamboo. So the ceramic are in the surface. The result of study show that there was an increase in water quality from the pond after the phytoremediation process. This is reflected from the decreasing density of the componema. This componema is indicator of eutrophic and organic pollution. The decreasing density of componema is indicate that the water quality is more good in the pond 3 after process of phytoremediation. And so based on the other index, such as the diversity index of Shannon-Weiner, we can see that they are increasing the water quality from heavily polluted to moderately polluted, and also based on the tropical diatom index and percentage tolerant value, we can see that increasing of water quality, they are increasing of water quality. This is from eutrophic to mesotrophic, and from heavily organic pollution to moderate organic pollution. This result can be seen too from the pie plot. We can analyze with PCA. Here we can see that phytoremediation process had succeeded to improve the water quality in pond 2 and 3, where have a significant difference compared to the pond 1. And in the pond 2 and pond 3, the value of the some water parameter is low compared to in the pond 1. So the conclusion here that evaluation of the water quality of aquatic ecosystem, both in natural and artificial ecosystem, can be done using bioindicator. And from our example, we can see that benthic macroinvertebrate and diatom or periphyton is effectively can be used as bioindicator of changing in water quality. So I think it's all from my from our talk today. Thank you very much. I'm sorry because I'm rather sick, yeah, and I'm back to the Bu Vicky Vidayanti as a moderator of this ICGRC. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Assalamualaikum warahmatullahi wabarakatuh. Thank you very much for a very brief presentation. Now we enter the discussion session. There is 3 questions. I think Also, I'm sorry. For question in the chat box, I will read it. There is, sorry. The first one from Mr. Joni Kusnadi for Professor Saiful Arif. Often we are faced with a dilemma situation in a limited area where there is a conflict between humans and wildlife. On the one hand, we want to conserve wildlife, but on the other hand, humans want a better life by utilizing land. As we know, wildlife conservation requires a large area of land. What should we do? This question for Dr. Saiful Arif. You still unmute.
Okay, right. Thank you. So I think the organizer control the microphone, right? Okay. To answer the first question, thank you, Ms. Vicky, and also thank you the question from Dr. Joni Kusnadi. Okay, the question is about we need to conserve wildlife, but at the same time, human need or to use land for their for economic development and so forth. So the question is, what should we do as wildlife conservation need a large area of land? So this is really a dilemma. Yeah, we want to conserve, at the same time we want to use the land. What should we do is at this time, many area, especially in the tropical area, Malaysia, for example, we don't have the proportion of the lowland area. Lowland area is the area that easy to access, right? Lowland is not so much left. It's only a few, right? So only hilly side has a very large intact forest, but still some development also include this critical area. So many of the effort conducted by agencies, government agencies or NGO or individuals, the common thing is we do the replantation area or reforestation area. But the question is how far the effort from us to do this kind of activity, reforestation or replantation. It's difficult because some land is owned by the private land. Yeah? So we have to ask the owner of the land, yeah, to use. Yeah. So how is the proper way? Meaning that the win-win situation. Yeah. The owner get the benefit and we also get the benefit. Yeah. So the second thing is what we can do is I think it's around the world try to do the ecological corridor. Like example I show in Peninsular Malaysia, we trying to do the connectivity, what we call the ecological connectivity. But again, the issue is how to convince the owner of the land to use their land to be part of the component of the ecological connectivity. That is the problem, right? This is very, very, really dilemma. Right? How we can, to make sure that the win-win situation, the wildlife and also the people, right? This is my response to this question. Thank you.
Thank you, Dr. Saiful Arif. A very brief explanation. And the second question comes from Professor Estri Laras. And the question is, according to your presentation, one of the solutions for wildlife conservation is by distancing the interaction between humans and wildlife. The question is how to do so. Will recently people try to interact a lot with nature to increase their love and concern for nature?
Okay, thank you for the question, Mr. Esri Laras. That is a very interesting question. We know that now there are many advertisements, right, in the television, in the social media. So we please we interact with nature, love nature, and so forth, right? It's good actually, but in my presentation, the interaction meaning that we are not use the animal in the improper way. For example, we poaching and then we put in the cage and then we selling the animal to the market, export to other country. This is something. This is the meaning of the interaction in my presentation. Yeah, because poaching, the trade. It's become easy when the forest become less and less in terms of size, and they are in the isolated form. So people can easily go inside the forest to get the animal and then to sell, because we know that some parts of the animal, especially the large animal, their body part like the horns, their skin is very, very valuable. So once we try to do some connection, for example, right? So we increase, we lessen the conflict, meaning the conflict between human and wildlife, meaning that the incidence of animal or wildlife going into the settlement area is become less, because they have enough space for them to roam instead of, or to get the food instead of they go to the settlement area. This is the meaning of the interaction in my presentation. It's not like the ecotourism. Ecotourism, of course, yeah, we the interaction meaning that we go to the forest, we love the nature, but we not use or we not harmful to the animal, right? We just observe and then we go back. All right, we see the birds, for example. We not poach the animal or shoot the animal, the birds, and so forth, right? So this is the meaning of the how the protected area we conserve, increase the importance. We have to sustain the protected area to ensure that wildlife or the animal have enough space for them to roam in the natural area, not to the human area. That's my answer or my response to this question. Thank you.
Okay, thank you, Dr. Saiful Arif. Another question from Professor Laras, but this is for Professor Catur. How effective is bioindicator can assess water quality in the term of time, and how long is a certain bioindicator can show any changing as a response to the existence of any pollutant in the water?
Okay, thank you very much for the question, Prof. Laras. I think it's depend on the type of organism we use as a bioindicator. We know that aquatic organisms have low mobility so that it will directly be affected by changes in the water. Polluted in the water will be affected to the structure community of the water organism. And then from our research before, if we use benthic macroinvertebrate for indicator of the water, we can use it's about 40 days after planting. So 40 days after planting of hydromacrophyte, there are many changing of the structure community of the benthic macroinvertebrate. But if we use diatom or periphyton, I think we only 1 week we can see that there are a different structure community. So it's depend on the type of organism we can use. I think that's for Prof. Laras. Thank you very much.
Thank you, Professor Catur. And the next question is from Dr. Sri Widyarti to Dr. Saiful Arif. What is your country's policy in dealing with resource sharing between human and wild nature?
Thank you for the question, Dr. Sri Widyarti, sorry, the Widyarti. Okay, regarding this question, our country's policy to deal with the resource sharing between human and wild nature, we have the Wildlife Conservation Act 2010, but now recently they revised the act. This act, in this act, we depends on this. We have to follow this, of course. For example, poaching or hunting, usually we based on the seasonal. Some animal, the wildlife department, based on this act, they still allow hunting for some animal like deer, for example, but seasonal. But they have to get the license from the department to do the activity. If not, they will be punished under the act. This is the act is used as the main tools to make sure that people still can use the resources. But in terms of the Aboriginal people, or we call it here in Orang Asli, there is the act that they are allowed to use the resources. This is something we call it special act for the Aboriginal people, because we know that among the Aboriginal people, their life depends on the most of them depends on the natural resources, but still the issues of their exposure to the modernization still affect, because now among the Orang Asli also they are changing their lifestyle. Maybe among the old generation, they still use the traditional way to use the resources, but among the young generation, especially the community that their settlement is very close to the urban area, that some parts of Peninsular Malaysia, the village of Orang Asli is very close to urban area. That is the issues. So how the modernization, for example, the use of the cell phones, social media, so they change their style. So compared to the Aboriginal people or the Orang Asli in the remote area, for example, in our national park, they still retain their traditional way to use the resources. This is some act or the policy that that our country have, how human and we can use the resources. Thank you.
Thank you, Dr. Saiful Arif, for the explanation. And the last one is from Dr. Chairat to Professor Chatur. Professor Chatur, have you ever heard about pollen scientists that use mussel to monitor water quality?
Yes, thank you very much, Dr. Chairat. Yes, but mussel in Indonesia, we know that in the freshwater is the density is very low. But if a gastropod, we have more density here in Indonesia. But maybe if the bioindicator is to the indicated of the water pollution in the marine, in the coastal, I think it's okay if we use the mussel. But for the water, fresh water, I think in Indonesia, I think that I rather it's because of low density. It's we cannot use that for developing a bioindicator. Yes, but I will try to know that for the mussel. Thank you very much for Mr. Chairat.
Thank you for the explanation and the answer. There is any question? Another question from the participants? We still have 10 minutes. If there is no question, I want to ask to Dr. Saiful Arif about your title. I want to ask to you, have you experienced a conflict when you do your experiment in Malaysia? There's conflict between your team research and the human or the community near the protected area? And
Okay.
Okay.
Okay, thank you, Ms. Vicky, for the question. For myself, I don't have any experience to counter the animal suddenly try to attack myself and my teams. But some area or some places, when I go there, yeah, they experience a lot about the conflicts, yeah, animals, especially the elephant, right? Got cause damage to their properties. Yeah? Some cause life, yeah, people life, yeah. People die about because of the attack by the animals, elephant, tiger, wild pig, yeah, wild pig now everywhere, because that animal is generalist species. So we can find the animal everywhere. Yeah, encounter suddenly the animal cross the road. Yeah, I experienced that once lah. Once during I driving along the highway, also can see the elephant. Yeah, how they try to cross the road. Yeah, so but not cause the conflict between us, but we just let them pass through the area. So that's why to build the connectivity, I think is a good or the one of the solution we can use to reduce the conflict between human and wildlife. Very difficult to say that we can evaluate, eliminate the conflict between human and wildlife, but at least we have to do something to reduce the number of incidents of conflicts between human and wildlife. Thank you.
Yes, thank you.
Thank
Very, very interesting explanation. Because in Indonesia, the cases is very different. When we want to get more protected area, sometimes we have a conflict with the human that live near the protected area. That is why sometimes we need more power to do that part. Okay,
the willingness from the politician,
yes.
right?
Yes, right.
It's very important. If not, we just say, we just do the research. We write in the papers. We write, put in the document, but we hope that it's not end at the bookshelf or our cupboard. But we have to convince the policymaker. But how? This is the question until today. How to solve this, right? Okay.
Thank you, Dr. Saiful, for the sharing.
Right.
And for Professor Catur, I want to ask about the can we give for community service? How can we teach the community to evaluate the quality and quantity of their water resource, and how can we do that?
Yes, thank you very much, Miss Mrs. Vicky. I think, of course, we can give socialization to the population how can we do if so the quality of the water is more good, because we know that not only the quantity of the water, but the quality of water is decreasing, and this is because of the human activity. So socialization about how the human activity can be done to the how the water quality we can serve to for evaluate the water is, I think, the population can use because we know that benthic macroinvertebrate is a big organism. So people can use the organism to evaluate the water quality, and then if the water quality is bad or not good, so the people can see that the human activity can impact to the water quality. So I think that's for your question. Thank you very much.
Yeah, thank you for the explanation. I think this is end of the discussion for the first plenary session, but I would like to read the conclusion. The first conclusion from first title from Associate Professor Dr. Saiful Arif is the protected area plays important role to reduce interaction between human and wildlife in the pandemic era. That is why we need to strengthen the protected area by by apply 5 steps or 5 things. The first is land use or land covering modeling. The second, management category framework. The third, conservation status of protected areas. The fourth, conservation of effectiveness. And the last one is ecological network system. And conclusion for the presentation of Professor Catur is water quality and quantity are affected by environmental degradation and human activity. in this pandemic era, the lab access is very limited. So we have to have another way to assess the water quality and water quantity by using biomonitoring, such as using benthic macroinvertebrates and peripiton, because some of the species can be bioindicator that the water or aquatic ecosystem have pollution. I think that is the conclusion for both of presentation. Before we end this first plenary session, I will ask to you to take a picture together. There is a 4th slide. So if you want to turn on your camera, it is okay, but please don't turn it off before I say finish. Let I start in the first slide. Give me some minutes. And the second slide. Third slide. And the last one. Okay, thank you. You can turn it off, turn the camera off if you want to accelerate the internet connection maybe. Okay, I think this is our end meeting for the first plenary session, and the second plenary session will be moderated by Dr. Irfan. Dr. Irfan, time is yours.
Okay, can you hear me, Bu Vicky?
Yes, I can.
Okay, thank you. So, okay, thank you very much, Mrs. Vicky. Before I open the session, I will greet our speakers. Good morning, Professor Barton. Okay, yeah, I think it's still muted. But
thank you. Yeah.
yeah. Okay, good morning. How are you?
Good. Yes.
Okay, good. Okay, thank you. For our next speaker, good morning, Professor Trisab Santon. Yeah, I think it's almost noon in Thailand and also in Australia, I think. Okay, yeah, I think it is good to see both of you again. Okay, I think I will start the session. Ladies and gentlemen, welcome to the plenary session 2. I will moderate through this session. And the session is divided into 3 sections, just similar with the previous section. So the first section is a presentation from Professor Mary Barton from University of South Australia, and be continued by Associate Professor Shairat Trisabsanton from King Mongkut University of Technology, Thornbury. Okay, the duration for the presentation is 30 minutes for each speakers. Then the last section is discussion time. Okay, before we listen a presentation from Professor Barton, I would like to read her CV. Oh. Okay. Professor Mary Barton. Her expertise is veterinary microbiology, public health, and food safety. So these are her recent publications. I will read only one of her publication at the top. It's about characterization of early microbial colonizers within the spiral colon of pre and post-natal piglets. Yeah, it's actually, for me, it's very interesting about the prenatal piglets. Maybe later I will read your publication. I will do stop share. Okay. Now for the next 30 minutes, Professor Mary Barton will deliver a presentation entitled Another Pandemic, Antibiotic Resistance. Please welcome Professor Mary Barton.
Well, thank you. Thank you for the invitation to speak. I realise this topic, this paper, is probably a little bit outside what the major theme of the conference is, but I think that one of the things we've learnt with COVID was that, okay, vaccines can be developed, but that's not been very easy, and that treatments have been even more difficult, and there really still isn't an accepted or generally accepted treatment that's widely available. And I think that we've had bacterial pandemics in the past, cholera, plague, and maybe there's not so much antibiotic treatment for either of those, but there is some. But we have an ongoing issue with foodborne infections, which seem to spread very widely, not just in the local communities, but also with food trade. So I think it's important to think about antimicrobial resistance. And the World Health Organization really says it all. I could probably just put this little slide on and say no more, because in a sense they really capture the essential issues, that it's a global health issue, it's of major importance right around the world, and really the driving force in this is the way that antibiotics have been overused and misused, both in human medicine and in animal production and in treatment of animals. But it also draws attention to what I think is the clear issue, and I'll be saying a bit more about this, is that we need to think back to some of the more basic approaches, and that is providing clean water, good sanitation and hygiene, infection control. Because if we can improve those, then I think we're going to make a much bigger impact on disease control and prevention than trying to rely on antibiotics. And we have to remember the cost is very...
Professor Barton.
Yes.
Oh, sorry, I think I cannot see your slide
okay.
presentation.
Okay. Well, I don't know what to do.
I think I can do it for you.
Can you do it for me?
Yes.
Okay, that might be better. Okay, you do it for me.
Okay. Sorry.
Okay.
Yes.
Okay. Look, my apologies for that. I'm a bit I'm not really very good at these things.
Can you see the presentation slide?
I can see the presentation. Yes.
Is it in full screen?
Yes.
Okay, it's good. Okay. You can say next if you want me to.
Okay. All right. I'll say. Okay. Yeah. That'll be much better. Okay. Next.
Next. Yeah. Okay.
Thank you. So what we have here is a statement, or not a statement. It's an extract from a World Health Organization, and as I sort of said previously, that really summarizes, I think, what a lot of the essential issues in relation to antimicrobial resistance. It's a global health issue. it's something that we really need to address, and we need to go back to basics. And I'll come back to some of these things a bit more later. But misuse and overuse of antimicrobials has really been the thing that's driven antibiotic resistance. And if we went back to more basic approaches of disease control, such as good hygiene, clean water, sanitation, we'd make a lot of progress. And we have to remember too that AMR is very, it's an economic issue. It causes significant problems, in terms of the economy. And if we keep misusing antibiotics the way we have, we've really run out of antibiotics for a lot of things. So we need to think of other approaches. Next, please. So if we look at this is a figure that came out a couple of years ago, but it shows that the way we're heading, deaths due to antimicrobial resistant organisms are going to be catastrophically high by the time of 2050, particularly in Asia, but also in Africa. It's really something we need to try and prevent. Next, please. Next, please. Okay, so we've known this since antibiotics were first introduced. Antibiotics really started to be used perhaps in the early 1950s. Penicillin was the first antibiotic, and it was developed in the late 40s. But Fleming, who was really the person that launched penicillin as an antibiotic, pointed out in 1945 in his Nobel Prize lecture that it's not difficult to make organisms resistant to antibiotics. And so he went on. And we just haven't learned from that. We sort of thought, well, if penicillin doesn't work, we'll find another antibiotic, and that will be good and we'll be fine. But we really are entering the post-antibiotic era. And so I think it's fairly pointless in lots of ways to just go on trying to find more antibiotics. We have to think much more seriously about how we manage infectious diseases. Next, please. So if we look at what are the major human health threats, these are just some of them. There are lots of others that you could put on the list, and you can see that the resistance profiles that these of concern. So with E. coli, for example, a very common organism causing infections, enteric infections, urinary tract infections, and other things, you can see that antibiotics there that really we haven't had for very long, and we're already threatening their availability to treat. So with E. coli, we're left with third-generation cephalosporins, fluoroquinolones, and extended spectrum beta-lactase. I'm not going to sort of read through everything on the slide. I think it sort of says what are the key antibiotics for these organisms, and where we're getting resistance to them is causing big problems. So with Staphylococcus aureus, methicillin-resistant Staph aureus is a major issue. And if we even move down to some of the more organisms that we see perhaps more regularly, things like non-typhoidal Salmonella and Shigella, fluoroquinolones are a key antibiotic, and if we don't protect those, then we're going to have big problems. And similarly, tuberculosis, with the pan-resistant tuberculosis strains now really key issues. Next, please. Next, please. Thank you. So what are some of I've already perhaps flagged what some of the key antibiotics in human medicine are. So we've got the third-generation cephalosporins, carbapenems, colistins, fluoroquinolones, and we've got some others that are very important. So these are antibiotics that we should be protecting, because once people become ill, then we've got to be able to do something about it. I think we've got to be doing more to try and prevent people getting ill. But when people are ill, we do want to have antibiotics that are effective and available to treat them. Next, please. So as I said right at the start, it's the use of antibiotics that drives the emergence of antimicrobial resistance. I've already pointed out it's a global issue, but it's a One Health issue. It's an issue, I'll have a slide in a minute to illustrate this, that you can't put it in little boxes and talk about infections in humans in one box and infections in animals in another box and environmental contamination in another box. They're all interrelated. And the antibiotic resistance genes spread very readily between organisms. And of course, that means they spread from country to country in their host organisms. So we've had experience with multi-drug resistant salmonella, for example, moving from the United States to Europe, Asia, and other countries. So, we've got to think about this in a very kind of One Health global sense. Next, please. And so, as I said, everything's interrelated, and this is a very old slide from 1994. But Julian Davies really was somebody who anticipated what was going to happen. So, and the slide is just as relevant today, as well, perhaps more relevant today than it was then. When the time he developed it, he was suggesting that this was the way things could go, and they absolutely have gone this way. That genes, antibiotic resistance genes, spread very readily through the environment from organism to organism. And so what we might have as organisms we don't think are pathogenic, they pick up these resistance genes and they can pass them on to some of the pathogens. So it's a very serious issue. And an Australian microbiologist called John Turnage said, we all swim in the same gene pool. And that's just so true. And we perhaps didn't think about that, in the early 90s, but I think we have to be really cognizant of it now. Next slide, please. So this is what I mean about we're all in it together. So we've got human medicine, we've got veterinary medicine, we've got antibiotics that are used in agriculture, some used for some plant infections. They often get, we often don't think about that. And so animals become exposed, but resistant bacteria and their genes get into sewage and effluent that gets spread around the place. So it's just all connected. Hospitals, veterinary hospitals, homes, pets, farmers. It's everybody, and it's all interrelated. And so we can't just take action in one bit and say that's going to fix the problem. One of the problems is, of course, in the medical sector, they keep blaming animals and saying, well, animals are the big problem, and if we stopped using antibiotics in animals, we wouldn't have a problem in human health. And that's absolute rubbish. Because there's huge problems with misuse and overuse of antibiotics in human medicine, in hospitals, as well as in the community. And there are problems in agriculture and in treating pet animals. So it's no point in you're trying to blame every other people. We've all got to take on responsibility for using antibiotics more responsibly. Next slide, please. And so this is an example of how some of these organisms can spread around the world. So carbapenem are very key antibiotics. So this is some organisms, Acinetobacter, which is causes hospital infections more than community infections, and E. coli. And you can see that carbapenems were not introduced all that long ago. And you can see that from this slide that these resistant organisms have spread almost right around the world. Particularly in Asia and in North America. Interestingly, not so much in Africa, because Africa countries, the medical systems there can't afford to use these antibiotics, and so they are carbapenems, so they tend not to have as much resistance. But in places where carbapenems are used, you see lots of resistance. Next slide, please. Well, okay, so we've talked about this really. So it's overprescribing, it's over-the-counter sales, and I realise that that's difficult in some cultures where people do go to the local pharmacy and buy antibiotics themselves. But I think this is something that those countries really do need to look at. And it's all sort of can be summarised as over-reliance on antibiotics. It's almost as though once antibiotics were introduced, everybody thought, oh, well, we can stop washing our hands and we can stop being careful about water contamination and, because we've got antibiotics. So if someone gets sick, we can give them antibiotics and they will be cured. Well, if it was ever the case, it's certainly not the case now. And as I said, we have to think about antibiotics in food producing animals. And for quite a long time in lots of countries, particularly more developed countries, some antibiotics were used at subtherapeutic dosages to make livestock grow faster. to a large extent, I think what they were doing was controlling subclinical disease in these animals, but that's a side issue. There's other ways of doing that. We use critically important antibiotics in pets, and we're just not using antibiotics. So it's the whole thing you could just summarize as saying inappropriate use of antibiotics. Next slide, please. And we can see the result of this. So this is some microbiome studies, and it's a bit difficult to read, but the very dark blue. This is human gut microbiomes from 250 odd volunteers. So the very dark blue ones are genes that determine resistance to antibiotics that are used in animals. So look, you see them. It's penetrated quite significantly into human microbiomes. The paler blue ones are ones that are approved for animal use, and the yellow ones are ones that are not approved for animal use. So the question is, where have these come from? Because obviously all of these people wouldn't have been treated with these antibiotics. Some might have been, but not to get that level of exposure to these resistant genes. So we've set up a pretty difficult situation for ourselves with the way we've used antibiotics. Next slide, please. And so if we just go back to sort of summarize a little bit, you can see that we had this sort of spectrum of antibiotics that we had, pre-antibiotics, and then there was a sort of a phase between the sort of early 50s to the perhaps 1970s, which you could say was the golden age of antibiotics, when lots of different sorts of antibiotics were discovered and introduced into human medicine. It sort of started to tail off a bit, and people were finding similar products, that the Me Too drugs, I guess. And then suddenly, we hit sort of late 90s, early 2000s, and there's a discovery void. No new classes of antibiotics. Really, we've kind of worked ourselves into a pretty difficult situation. Okay, next slide, please. And so this illustrates this even more starkly, I think. You can see it just shows the timeline and the antibiotics at the times they were introduced. And you can see that, but sort of in the 1950 to the late 70s, early 80s, perhaps, there were lots of antibiotics coming onto the market. And as illustrated in the previous slide, since then, we just haven't had any new classes of antibiotics found. Next slide, please. So people obviously, part of the problem that this is a complicated problem, I guess. Part of the problem was that the big pharmaceutical companies decided that antibiotics really weren't something they wanted to continue, because the idea of giving somebody an antibiotic is that you make them better and they perhaps take the antibiotic for 5 days or short course, and then they stop taking it. So the big pharmaceutical companies were sort of concerned about their profits, because people weren't, it's not a lifestyle drug like drugs to control blood pressure or drugs to control, statins for blood cholesterol, because people have to keep taking those for the rest of their lives. Antibiotics, people just take for a short period of time. They suppose that they get better and they stop taking the antibiotic. So where's the profit in that for the big pharmaceutical companies? And of course, the other thing that happened was, and it's perhaps a bit apocryphal, but the US Surgeon General is alleged to have said in the late 60s that the pharmaceutical companies should stop investing in antibiotics, because we have plenty of antibiotics. So that was kind of the peak of the golden age of antibiotics. And he said they should be concentrating on other drugs like anti-cancer therapies and so forth. And they did. So what happened when the pipeline dried up? Some small pharmaceutical companies started getting into antibiotics and trying to find them, and really the pressure to find new classes of antibiotics, because that's what people think is the best way to deal with this. And as I've said, I don't necessarily agree with that, but they started investigating new sorts of antibiotics, and this just sort of in a way indicates that since 2014, there have been 7 new antibiotic products registered. They weren't new types of antibiotics. They were variants on existing antibiotics, and a whole and work in research. People, as happens in everything, people have started to find or investigate antibiotic properties of particular drugs and then discontinued it. And you can see that the green boxes suggest that these are novel products, novel antibiotic products, but you can see there's not very many of them, and most of them are for hospital infections. Okay, next slide, please. And the other problem, the issue that I've sort of alluded to but not been explicit about, is that almost as soon as we introduce antibiotics, we find resistant organisms. So bacteria are very, I guess we used to sort of, I suppose you sort of, as a student, you sort of thought of them as these microscopic things that you can't see and you can kill pretty easily. Well, antibiotics have been around for billions of years, and they've been dealing with adverse single-celled organisms, dealing with very adverse environments. And so they've become very adept at utilising mutations to ensure that they continue to live. And so that's exactly what they did with antibiotics. So penicillin was introduced, well, first discovered in 1928, wasn't introduced into medicine in about till the 1940s, but resistance was seen straight away. And similarly, you can see methicillin resistance was found not too long later. So, but the problem gets sort of accelerates as you get along the line. So things like in the middle of the roughly in the middle of the slide, above resistance development, you can see imipenem and ceftizidime. And resistance, they were introduced around 1985, and resistance was seen by 1987. Linozolid was introduced in 2000, and resistance was seen in 2001. And I could go on. And there are plenty more examples apart from these. So, what's the point of continuing to make new antibiotics if all that's going to happen is that emergent resistant organisms are going to emerge really quickly? We need to take another approach. Next slide, please. So one of the things, obviously, is we as I've said, we still are going to need some antibiotics, because once people get sick, we need to try to treat them. So people talk about antimicrobial stewardship, and they talk about the 5 R's of antimicrobial stewardship. So that the people that pharmacists and doctors and vets and other people that provide antibiotics need to accept responsibility for resistance, and so do people that take antibiotics. We need to accept that resistance is a potential result of antibiotic use, and we need to reduce, replace, refine, and review antibiotic use. And on the animal side, we need to recognise that there are potential adverse effects of using antibiotics in animals on human health. We need a regulatory framework. We need a regulatory framework that's going to register drugs properly and controlled, and we need controlled prescribing. We really can't continue with this situation of people being able to just go and buy antibiotics in a shop and treat themselves. And I know there are financial implications in all of this, but I think there are bigger financial implications in allowing more resistant strains to emerge. We need to have antimicrobial resistance surveillance, so we need to be keeping an eye on what's happening, and there is various parts around the world, countries are working at this issue. And we need to think about new therapies, new approaches. So what can we do to control infectious disease that doesn't involve use of antibiotics? Next slide, please. So various things have been proposed. So we've got molecules such as, these are orally taken prebiotic organisms, so oligosaccharides that can be incorporated into the diet that will change the microbial flora and inhibit the growth of the pathogenic organisms. Similarly, I guess probably more developed probiotics like lactobacillus and enterococcus and so forth, and again to improve the microbiome in the gut and on the other parts of the body, to make them microbiome more stable and more resistant to invasion by other pathogenic bacteria. and also with some of these probiotics, the production of bacteriocins or killer molecules produced by the bacteria themselves that will kill some of the pathogens. There's been a lot of attention paid to bacteriophages and trying to use bacteriophages to treat infections and also extract the lysins from these phages and use those. And although phages are certainly very potent, it's proven very difficult to actually commercialize them or channel them in a way that means they're a realistic treatment. They're okay, in small numbers of cases where you can grow the organism that's causing the infection. You can find some phages that kill that organism, and away you go. So it almost has to be sort of like customized medicine on a patient by patient, organism by organism basis. And that's really not a realistic approach. The phage license are perhaps maybe a way ahead, but I suspect that we'll find that the bacteria will be resistant to those too before too long. Now, vaccines are very important, and vaccines have proved, and I think that's where we probably need to put even more attention. I guess some of the organisms that are left that we don't have good vaccines to prevent are the more difficult organisms that we've tried for a long time to make salmonella vaccines, but most of the ones that have been made are not terribly good vaccines. Certainly E. coli, we don't really have vaccines for E. coli in human medicine, and there are experimental ones in animals, but then again, not very effective. But so I think more attention needs to be paid to vaccines. And then I think antimicrobial peptides, and I've already mentioned those are bacteriocins that are produced by lactobacillus, but people have talked about isolating these antimicrobial peptides and using those, but I suspect that the bacteria strains would soon emerge resistant to those. Next slide, please. So what's happening in terms of these non-traditional products in development? And you can see from the slide, so the brown at the base are antibodies, then the next one up are the dark pink are vaccines. Then the next one up is live biotherapeutic products like the probiotics. So it goes on up the list. And you can see that in terms of clinical trials, that the field narrows pretty quickly once you get to phase 3 trials, so that there's one antibiotic inactivator, one phage lysin, 2 live biotherapeutic products, and one each of vaccines and antibodies that are in phase 3 of clinical testing. And I can't remember just off the top of my head what they're for, but that really is not going to, that helps. It's a start, but we've got a long way to go. Next slide, please. So instead of using antibiotics, so again, I guess I'm hammering this. We need public awareness and education to understand what the issue is, and that people need to be applying some of the more simple methods of infection control, hygiene, and so forth. Vaccines, obviously. Then in animals, we need to find in those countries which are still using antibiotic growth promotants, we need to find other products, and there certainly are other approaches that could be used. Farm management, we need to think about, in Western countries, and I think to some extent in Asia as well, agriculture has been intensified. So we have aquaculture, we have intensive chicken production, in some countries, intensive piggeries. Maybe we've got to stop this and go back to having less intensive farming, because if you have less intensive, animals are not clustered together, disease is going to be less of an issue, and so the farmers won't be wanting to use antibiotics. We need better hygiene, isolating sick animals, safe disposal of carcasses, not just throwing them in the river or burying them so where the water table becomes contaminated. We need clean water sources, chlorination perhaps. And we need to think about things like improving, and this has happened already with chickens, genetics of livestock, so that if we manipulate the genetics of livestock to reduce dependency on growth promoters. We already have the situation with meat chickens that they will grow to the commercial strains of meat chickens will reach marketable size within 5 or 6 weeks. But if you start trying to make them grow more quickly than that, their bone structure won't support them, and they end up in a real mess. So the genetics have driven these animals to be very efficient feed converters. But if we try and add antibiotics into the top of that, that makes a real mess. And then manipulation of microbiomes with things like fecal transplants as a treatment. And that's certainly been used for Clostridium difficile infections and for a few others. But I think there's an opportunity to use this more broadly in human medicine. It's probably too expensive to use in animals, but it certainly works in pigs. But whether it's a feasible commercial thing is another matter. Next, please. And then in the environment, we need to think about the environment. This is part of the picture too. And we know flies carry antibiotic-resistant bacteria, so we need to control insect pests such as flies and cockroaches and so on. And we also need to think about wildlife. I mean, there's quite a lot of papers now from Europe and from Australia and other places showing seagulls scavenging on rubbish dumps carry highly resistant organisms, and they spread these around. And we need to think about collection and treatment of manure and sewage better. Okay, next slide. So I'll just go through a few slides just fairly quickly about where we have reduced antibiotics, reduced use of antibiotics in animals, has this had any impact? So next slide, please. So this is a slide from showing removal of Keftiofur, which is a third generation cephalosporin from chicken hatcheries. It was used when the chickens were injected in ovo with vaccines, which is a technique that's used in chicken production. They often put Keftiofur in with the injection because obviously the risk of introducing a contaminant into the developing eggs was significant. And they used Keftiofur, and what they were seeing was that as a result of the use of Keftiofur, there was a significant outbreak of Salmonella Heidelberg, which was spread into humans from chickens. And the Salmonella Heidelberg was resistant to Keftiofur, or these third generation cephalosporins, as was E. coli. So they withdrew Keftiofur, and you can see that very quickly the resistance in the Salmonella and the E. coli dropped. And then for whatever reason, they allowed the farmers 4 years later to reintroduce Keftiofur, and you could see immediately the resistance levels sprang up again. So that's one example. Next slide, please. So this was in pigs using macrolides like erythromycin-like products in pigs, and again in 1997, Denmark took a lot of action to remove use of growth promoting antibiotics, and macrolides were one that were used. And you can see that the resistance in Enterococci, in Enterococcus faecium and Enterococcus faecalis, dropped very quickly. Didn't get back to zero, but it dropped. Okay, next slide, please. Avaparcin, which is a vancomycin analog. Again, you can see withdrawal of avaparcin from using as a growth promotant in chickens. The resistance in Enterococcus dropped very dramatically, virtually to not detectable. Next slide, please. And this is a bit messy, but this is it's extended spectrum cephalosporin resistance. And what this one shows is the resistance gene. So if you look down the bottom with the coloured boxes, don't worry too much about the colours. You can see that when the change occurred in 2010, they removed use of this antibiotic in pigs in Denmark. It took a little while for they removed it in 2010. You can see by 2011 that it already started to drop, and so it's effective. If you remove antibiotics, you can reduce resistance. You probably won't get it back to zero, but you can reduce it significantly. Next slide, please.
Professor Burton. Oh yeah, okay.
So in conclusion, I think antimicrobial resistance is a huge public health risk around the world. The antibiotic pipeline is not promising. So we need to manage what we have properly. So that means we need to use antimicrobial stewardship and manage the use of antibiotics very carefully. And we need to go back to basics. We need to think about things like hygiene and infection control, and sort of non-antibiotic alternatives for treatment. We need to think about how we raise animals for food. We need to think about reducing intensive agriculture so that disease spread is not such an issue in animals. And we need to think about how we deal with human and animal wastes. Thank you.
Okay, thank you, Professor Barton, for your presentation. So our next speaker is Associate Professor Hairat Tri Sabsanton. I will read his CV first. Okay, this. Yeah. So his expertise is about environmental remediation, and his current recent publication is effect of licit effluent water reuse on the phytotoxicity and micropollutants accumulation in agricultural crops. Okay, I think that is for his recent publication. I just read only one. Okay, now for the next 30 minutes, Professor Tri Sabsanton will deliver a presentation entitled the technology for reducing environmental threat. Okay, please welcome Professor Tri Sabsanton.
Okay, so thank you very much for your nice introductions and good morning, everyone. So, so today I am going to share the idea about the sustainability development in Thailand after COVID-19. So this is just a kind of sharing my experience. Do you think that sustainability is like this? So there is so many countries, so many cities, many countries around the world, like in London, in Paris, or even in Bangkok. Yep, everywhere is very beautiful, and there is so many things to do in these cities. However, do you need the city around the world? Do you need the growth of the industry like going like this in whole of our planets? Okay, let me zoom in from the sustainability. So inside the city, there is so many waste, like plastic waste or wastewater, and also the air pollution that gonna contaminate a lot inside the city. And is this return to our question that what is the sustainability? So we would like to grow up our world in this way or not? And then based on the data, so we try to calculate that how many resources in the world that we need. So in America, if we grow the numbers of the human population like what we have now, so we need around 1.6 world. Only one planet is not enough anymore for our growth rate like this. So for example, in US, they need 5 planets of the Earth. And also you can see from this slide. So it is not possible that our world and our development is going this way. So we have 2 choices. So 1, we make the world better. And 2, we go out of the Earth and then go to find somewhere else in the spaces. And then the lockdown periods already inform us and make sure and confirms the idea that humans make pollutions. So you can see the comparisons between the general times, normal times, and also when we have the lockdown periods. So you can see the pollution is reduced a lot in many countries around the world. Also in China, in India, in Paris, or even in Bangkok. So this already confirmed that human activity have the problems. Because of us, then the world have a pollution, then the world have the waste, and go on. And we cannot go on this way anymore. Although the lockdown period may reduce our air pollution, but then they generate another waste, especially hospital waste or contaminated waste, as you can see here in Thailand. Some people, they just throw away the glove and the mask on the way, and you can see huge, often all of the plastic waste happen during these periods. And then we have the manager in Thailand and many private company in Thailand. We are together thinking about how to sustain the world, how to develop the technology to reduce the waste happen nowadays in Thailand. So we think the model we call like BCG model, like biocircular green economies, that every time when we do wedge between the financials, economy, and environment, every time finance will be win when we wedge between these two. So nowadays we have the idea that when we have to wedge between the environment and also economy, we have to give the value to the environment more. And then we try to making the new model that we're gonna grow up together with the economy and environment. And then we create this model, and then we ask like private companies and also universities and everyone in Thailand, we have to realize our way for the sustainability of the world. For example, like contaminate world. You know, when we talking about the kidney wash, you know, kidney disease, right? And then when we have a kidney disease, we need to wash our kidneys. And then this is just an example, like there is the waste from the bag of the drugs we wash from the kidney. But the bag below, they have the contaminate with the human something like human waste. But the bag top there is clean. And then we realize that the bag they use for the drugs is very strong and have the how to say strengthness the same as the leather of the cow. And that is the idea to make this one to the bag. And nowadays we have the company that we sell this bag, and then this is a kind of recycle technology. Also the plastic waste in the oceans. The private company, they take the plastic from the oceans to make the carpet. The company in Thailand, they make the carpet. And on the carpet, they also immobilize the nanoparticle that can kill the COVID-19 and also some virus for the 4 step. So step 1, step 2, 3, and 4. And then your food will be clean from the virus. And then they implement this carpet to use inside the department store in Thailand. And also, I think everyone knows the Starbucks. And we have the support from the Starbucks to build the furniture from the waste, from the coffee. Actually, Starbucks have a lot of the coffee waste every day. And then we have to take that waste and then put some ingredient to make it artificial wood. And then we use that one to build up the furnitures. And then Starbucks will buy it and use it. In every Starbucks in Thailand, the furniture is made from them own coffee waste. And also every day we have like 50,000 of the eggshell. And then we also use the eggshell to make like artificial stone. And we also develop as furniture. This is to export the furniture to many countries around the world now. Also in our laboratories, we also we use many waste from many sources actually. So we have the seashell, we have the waste from the tea and some microorganisms. Then we develop the fertilizer, and also we study the plant stage, and together of them we try to commercialize our product that we use the waste to build it up as a fertilizer or maybe the plant nutrients. And after that we try to force for the startup, for the new generations of the people nowadays. They would like to be startup, they would like to be entrepreneurial, they would like to have the entrepreneurial mindset, and then we try to build that one, and then try to force our knowledge to the products, and then and then ask them to go on in the market. And for example, like our lab, we also develop the wastewater treatment system from the agricultural waste, like cassava waste, like coal pit and coconut shells, and then we try to make it as a bead, and then using this one into our system for the absorbent. And also we develop the air pollution treatment systems, like as you see here, and we also have the patent. Nowadays we have like 40 companies in Thailand. They are our customers, that they use this system to treat out their water. And also we try to develop the air pollution treatment system at the same time with agricultural waste. And this is an example of the studies, like they have the good efficiency for benzene removal. And because of the material that we use, they can absorb a lot of benzene comparing with the control white color that we didn't add any material. So this result already confirmed that the material have the potential enough to continue develop. And from here, return to one of our part of the studies. Long time ago, like in America, they have the BC Wolverton, they do study about how to use the plants to remediate the air pollution in 1996. And then the experiments go on into 2001 in Australia. Professor Topis, he studied the screening of the plants to remediate the air pollution. And then in 2012, our experiment in our lab, we continue our studies. And after that, we believe that the plant in the tropical zones should have the different efficiency compared to the plant in other zones of the world. And then after that, we know we have the database that which plant is the best. And then we try to use some chemicals or some biological methods or even physiological like LED light to improve the removal efficiency of the plants. And then even we use the plants, we use some method to improve the efficiency. Then we need to go on with the innovations. As I told you that we try to force everything to the market. And then we go on with the develop our innovations like the smart pot for the air pollution treatments. This we start in 2018, I think. And then it came to this thing. So this is like a kind of the robot for the phytoremediation technologies. We grow the plant on this side of the robot, and then the robot gonna inform us that how the plant behavior is, like how much temperature now, how much pollution around the system now, and how much the humidity on the soil now. And then we also try to use these machines to remove the air pollution, and then the efficiency is shown in this graph. Like they remove quite a lot, like 60% until 80% of total VOC, and also they also can remove the PM 2.5 inside the room. And we also present these machines to the private company. Okay. And we also do simulations that, okay, if we put the machine on the room, how it's going. And then we do simulation that the flow of the system gonna be like what you can see here in the quick video. And then because of this, and then we also develop the bigger system that we're gonna put it outside the buildings. Like in here is the outdoor system that we can merge many technologies onto it. This is the very good skill nowadays that every new generation should have, is the multidisciplinary. You are biologist, but you need to know also some electronics, some smart farms, some smart system. For example, in here, you need to also, in here, we merge many things together. I am biologist, but I have to do study or do understand the electronic work, like how to develop the LED monitoring the air pollution around this system, the PM 2.5 humidity sensor, and also do the watering the plants automatically. And then it become this system. It become this system. So the system, we add the people that we add the chair that people can sit down here. And also the movement of the air, the zigzag airflow add inside the system that gonna increase the contact times. And also this increase the air pollution removal by use the air phytoremediations. We also add the cloud that the many sensor gonna send the data into your computers. And also this is we add the smart farm that the system gonna watering the plants automatically and all controlled by your phone. And the real one is already built. So this is the real one that we already built up, and then we already test the efficiency during in different distance, and then we get the efficiency is like this. So the system gonna remove our PM 2.5 around 60% in each different distance far from the system. And the people who sit down here this side gonna expose to the good air that already passed the green zone. And phone controllers that you can see on your phone, and then you can watering the plant by your phone. You may be in Korea or you may be in America, you can water your plants. And because our data, like our knowledge about air phytoremediations, our database, a lot of plant, we know that how much efficiency each one is in top ranks in the world. Actually, we are in top 5 of the world in this area. So we try to develop like 3D visualization. So we have the plant museums that you can visit this website and you can see our museums of plants that show the efficiency of each individual plant, or you can merge this technology into your metaverse. That's gonna be a new technologies coming within these 5 years. So this also have the database of the plants. We also build it with the private company in Thailand as a website to show the data. And then because we already developed the green wall to remove the pollutions outdoor. So with the company in Thailand, we also developed the bus stop. We try to build the bus stop that the people that waiting for the bus will be exposed to the clean air. And then we try to study the efficiency of it. As you can see here, the bus stop, and then the people are gonna sit down here and then expose to the good air. And also in Thailand, we about this company MQDC, like they really interest to develop the world in sustainable way. So they try to build up the forest and merge the forest and the condominium and house together. So you can see this area, they would like to build the forest here. And then this forest, what is different between forest and garden? So normally garden, you need to give the water to the plants, but the forest, it means the plant itself can survive and without any watering from the humans. and then they will not allow the people to get in. This will be very quiet zone that no people here, and then they try to merge the forest and building together. This is just as this is not just the idea, but it's happened in Thailand, in Bang Natrat Road, in Bangkok already. And not only the environment, we also care about the future energies. Like in here, we try to develop the microbial fuel cell together with the wetland. And then the bacteria in the root gonna produce the electrics by using the phosphate and nitrate inside the water. And then the plant gonna provide some nutrient that gonna serve to the bacteria survival. And then in here, I already success to apply this system to produce some electric. As you can see in this quick video that some light already show. This is just some small quick video, just a little energy we harvest from the systems. And then we are thinking about how to collect the power from this thing, from this tube, and then how to apply in practical way more. And also we try to build up the light illuminating plants that the plant gonna illuminate the light. Imagine if you have the forest like this, and then one of the plants inside can illuminate the light. It's gonna be something like fantastic. So we also get the research patient from the private sector in Thailand, and then we do continue our developments, the plant to illuminate some light. And then this one, we plan to grow it inside that forest building from the private company in Thailand. And then maybe we're gonna build up the avatar world. And not only like plant take care us, but we would like to take care plants also. So we would like to understand and talk to the plants. So nowadays, like some plant like mimosa or some fast response plant like this plant, if you attach to some part of the plant, it's gonna give you a signal like this quick video is our experiment. When we touch something onto the plants, and then the plant gives us the signal. So we are thinking about if we can follow that signal, we may be possible to understand more the plants. Maybe they need water, maybe they have a stress with the light too much or too low, for example. And then not only the first choice to make the world better, we are also thinking about how to jump off the world. That is, I don't want to be on this way. However, we need the technology to support. Like for example, like in NASA 2000, maybe somebody in this conference might heard about NASA Lunar Outpost 2030s. That NASA, nowadays astronomy that survive outside the Earth, the maximum is only 3 days. But NASA would like to survive on the moon, like around 6 months. So we have to, and then they call every scientist around the world, please try to find some new knowledge to support them to be and survive on the outside the Earth to be more than 6 months. So it's gonna be the second choice. And our experiments that published the paper last year, we do the experiment like simulate the microgravity and growing the plants on it. And in these machines, the plant gonna expose to random positionings. So the root of the plant will change, the leaf of the plant will change. And based on the omics data, the behavior of the plant on this machine is almost the same as on the space. So we use this one as a model to study the behaviors of the plants to grow and crop the plants outside the Earth. So the trend after COVID, because this conference, the theme is like post the COVID. So after the COVID, what happened? during the COVID, everyone thinking about, everyone like is a kind of accelerations. Many technology happened during this period, like Zoom. We don't know Zoom before, but then nowadays Zoom is, we use Zoom in many meetings. And also, you know, Internet of Things, IoT, is the thing that everything is on internet. And sustainable development goal. So this is something we have to think about, how to make the new normal to be real, to be normal, like work from home as a normal. And also coming soon will be like metaverse and e-commerce will be expanded. If we are thinking about in America nowadays, like the people don't want to work anymore after they work from home for so long. Then they realize that they ask the question themselves that why they have to work. They work for their families. So they don't want to return to work again. And the people in America now, they try to exit the work, and they don't want to work anymore. So some company, they already established the 100% work from home. Or is it possible about robot, about lab from home? And also the reason is because the meaningless of their lives, and also the burnout during this COVID-19. So this we have to take care of. So my talk today is about to share what happened in Thailand, and also if we want to go on together, the future is in your hand. Sustainability together with many things gonna change after this. So thank you very much.
Okay, thank you very much, Professor Risab Santon, for your presentation. So now we move to the third section. It's a discussion. So for any participant who has a question, please raise your hands. Click raise hands, yeah, in the Zoom meeting panel, and also you can write down your question at the chat column. Okay. Maybe at first I want to read a question from a chat column. It's from Dr. Srividyarthi. The question is addressed to Professor Haribartan. Would you like to give your opinion whether human life can free from use of antimicrobe? Thank you. Okay, please.
Look, this is really complicated. If you just think about it, less than 80 years ago, we didn't have antibiotics, and people lived, and I guess people died. But in a sense, I think we've made a real mess of using antibiotics, and we've now become dependent on them. I think we'll always, to me, I guess there's always going to be a need for some antimicrobial treatments. But if we don't stop what we're doing, they're just not going to be available. We've got to find other ways of handling infectious disease, and just reserving antibiotics for the times when we absolutely have nothing else we can do. But I'm a little bit pessimistic about how long we're going to have antibiotics available. But thank you for the question. It's a thoughtful question.
Okay, thank you for answering the question. I look back to the chat column. Now it's from Professor Johnny Kusnadi. The question is addressed back to Professor Haribartan. We realize that there is great potential for resistance to the use of antibiotics, but it is now difficult for humans to avoid using antibiotics. Because in addition to the reason for the treatment of disease, the use of antibiotics also has an economic motive behind it. What should we as individuals, families, and scientists do to prevent the overuse of antibiotics? Okay.
Look, again, a really good question. I do think a lot of it has to be that we go back to basics in terms of what we can do to prevent infectious disease occurring. So hygiene, hand washing, clean water, looking after food properly. I think as scientists trying to find, are there alternatives? I mean, maybe, vaccines, I think, are the clue. The way to control some of these things is by improving the immune response and the health of the human or the animal, so that the organisms just don't exert their bad effects. But I think we've got to stop people thinking, well, yes, if I get sick, I'll just go and get an antibiotic and I'll get better. I think that's one of the major things that has to happen. Thank you.
Thank you for answering the question. Okay, does anyone from the participant have more question that need to be delivered to any of our speakers? Yes. There is a question. Yeah, this one is addressed to Professor Hairat. My name is Abdul Masud from Hiron University. The question is, what is medical waste products from the COVID-19 pandemic have the opportunity to be processed with bioremediation? And is it safe for technology players and consumers because of viral waste? Okay, please.
Okay, so actually, we have to separate two things, like the waste is contaminated or not. So if the waste is contaminated, I don't agree to apply that waste to be something like recycling. However, if the waste is not contaminated, like, I don't know, some waste from the hospital, but it's not contaminated, they will separate. So we have to think about to use it. So the way, I mean, the way to reduce the waste, I have read one article, like when we throw away one waste, like for example, like plastic gas here, they generate the waste more than the plastic gas, around 33 times. So, during the process to produce something, they have a lot of waste and they consume a lot of energy. So we have to realize our way and try to reduce from the start. But if you have no choice, so you have to separate like two waste, like one contaminate or not. But if it not contaminate, so you can do recycling. But if it contaminate, I not recommend. And the phytoremediation or bioremediation, they can be used for the wastewater, for example, and some air pollution. But for the plastic waste, I'm not sure about that. I never heard, and I have heard that there is some worm that can eat the plastic, but I don't know how fast or is it valuable enough or not. So for that question, I hope I answer the questions.
Yeah. Thank you for answering the question.
Uh-huh.
So we have another question.
Uh-huh.
It's also delivered to Professor Shairat Desabsanton. It's
Uh-huh.
from Dr. Dodi regarding the slide wetland microbial fuel cell. Is it possible to develop it further into a renewable energy source like other bioenergy?
Okay, so I recommend the Dodi, the one who asked me these questions. I give you the links by OOText. This is really, this is already commercialized the technology that they merge the plant microbial fuel cell together with the battery on site, and they try to collect the power inside the batteries, and then they use the battery for any other thing they want to use the electrics. However, yeah, it's already commercialized in Europe, but I am thinking about in Asia. So we need to think about this also. So if you ask me like it can be renewable energy source or not, yes, of course. But it's valuable enough. I think it's an optional power. You cannot be used this technology to substitute the petrols or nowadays power source. Not yet. Thank you.
Not yet. Yeah. Okay. Thank you for the answers. Does anyone from any participant have another questions? Yeah, we have a very interesting topic in this section. Okay. We're waiting for another question. I have a question, yeah, for Professor Barton. As I know, antibiotic resistance is always hot topic, yeah, in everywhere in the world recently, yeah. But in my question is, will the resistance can still occur if we use alternatives compounds such as plant extract or maybe also probiotics, yeah, instead of the antibiotics? Because as we know that the plants and the probiotics can also produce an active compound that can inhibit the growth of a pathogen.
Yes, look, it's an interesting question. I think that there may be some opportunities with some of these natural products, but you have to remember that bacteria are evolved with plants in soil ecosystems, and there are bacteria that are intrinsically resistant to some of these natural products. And so the question is whether other bacteria that at the moment are sensitive, will resistant strains also emerge? I think it's a very dynamic, bacteria, I think, have very dynamic relationships with their environment, and they will unless you find some way that sort of totally destroys them. I think we're always going to have this problem of resistant strains emerging, maybe at a very slow rate initially, but I think I'd put my money on the bacteria, quite honestly.
Okay, so there is a possibility to have a resistance. Okay, thank you for your answer. So my next question will be addressed to Professor
Irfan.
Yeah. Oh yes.
Can I have
yes question?
more additional question to Professor Mary Barton?
Yes. Okay.
Okay. Thank you very much, Prof. Mary Barton. As you know that the antimicrobial is not only antibiotic. Is it possible to change the use of antibiotic with other antimicrobial substances, for example, like bacteriocin and other antimicrobial substances? This is more safe than the antibiotic, and maybe not cause the antibiotic resistance. Thank you very much.
Look, that's a really good question, and I think there is already we've had products where we've had dual products. So we've had things like sort of clavulanate added to some of the penicillin. So just another chemical molecule. So the options of trying to work with natural products and bacteriocins is really interesting. I don't know whether anybody has really looking into that at this stage, but it's certainly a possibility because, I mean, as you know, that if you, you know, a lot of the way that with bacteriophages, for example, the way to make bacteriophages effective is to have take a multiple group of bacteriophages and use them at the same time, so that the organism just does not have a chance for to sort of produce resistant strains. And I think that if you could have this sort of co-administration of some of the traditional products along with traditional antibiotics, along with some of the bacteriocins, it may well be a way of doing that. But I'm not, you know, I guess I'm more at the resistant end rather than developing the antimicrobials end. So I'm not aware of what work's going on at the moment, but it's certainly an interesting idea. So thank you.
Thank you very much.
Thank you for the answer. Does anyone have another question from any participants? Okay. Yeah, it's for Professor Trisabsanton. I have a question. You have presented several potential technologies, and it's very interesting. Yeah, it's to overcome environmental threats, and it's you show the advantages, yeah, the advantages of those technologies. Yeah. So based on your opinion, I want to know whether those promising technologies have a negative side effect to the environment itself. Yeah, like antibiotics in case of what is presented by Professor Barton.
Yeah, that we have to think more. That's gonna be like, you know, sorry to say, like nowadays we have to when we develop every innovations, we cannot just think that if the innovation is new, the innovation is benefit or and improve the well-being of the human. We have to think about if also improve the environmental also. We have to always think that when we develop something, we have to think for environment. Even we have to pay more. Even it's gonna be a cost for every innovations. We have to put this criteria that we never have it before. So the next generations of the people have to face to these disruptions. Let's say environment doesn't force us now, but we have to do it immediately. It's not just how to say, like 5 years ago we discussed, I think like more than 10 years we discussed about environmental problems, but no one act in realistics. So now environment alarm already, and then we have to always think about it. Every technologies nowadays, from now on, we have to think for environment, in my opinion.
Thank you. So we need to re-improve every technology that is used today. Okay. So still have 15 minutes. Does anyone have any question? Okay. I think if there is no any questions from any participants, I will read a summary. Yeah, for summary about the presentation. Oh, raise hand. Oh yeah, sorry. Okay, there is a participant. Will give a question, please, to Dr. Sri Widyarti.
Okay, thank you, Dr. Irfan Mustafa. Prof. Mary, I would like to know your opinion. The antimicrobe is the focus in antimicrobe is in the pathologic microbe. Uh, it is true. If in our body the pathologic microbe is should be zero, or pathologic microbe in our body can be in a little population, but not infectious. It is what's your opinion about that, Prof. Mary? Thank you so much.
I'm not sure I understand what you were saying, that we can be exposed and to low levels of pathogenic bacteria and not have any ill effects. Is that what the question?
Yeah, in antibiotic, I think this antibiotic focus in killing the pathogenic microbe. That's right.
Yes.
Yeah. Okay. Actually, this microbe is little is the little friend in our body. Little friend in our body. Is the pathogenic microbe should be zero in our body, or it should be zero in our body?
Well, not necessarily. I guess what you're really trying to do with using antibiotics is prevent disease occurring. So you want to kill enough of the bacteria so that the person doesn't get sick. And I think in many cases you don't kill all of the bacteria, but the immune system and other things will protect the body from what's left behind. And often, we're exposed to microorganisms, pathogenic microorganisms, and we don't get sick. And we don't get sick because our immune system and the normal microbiome that we have in our intestinal tract or on our skin prevent these other organisms multiplying to any large extent. They might multiply a little bit, but they don't really get to be present in enough numbers to cause disease. So antibiotics, it's not necessarily aiming to kill every single microorganism, because and I think that's probably would be silly, because really what you want to do is to enable the human or the animal to mount an immune response themselves that will control that microorganism and stop disease occurring. Does that make sense?
Okay, thank you, Prof. Mary. It makes sense. Thank you.
Good question. Thank you.
Okay, thank you.
Is there any question? Okay. I think I will give a summary from our presenters. First is from presentation from Professor Barton. The overuse of antibiotics has led to the emergence of non-treatable infection. Professor Barton recommend us to go back to basics, to leave antibiotics and reconsider how we deal with infectious disease. And of course, to success these big steps, it should be applied or it should include human, animal, and environment itself. Okay, and from Professor Trisabsantorn, there are many ideas for world sustainable development. Mainly, it is divided into three parts, which are waste, recover and recycling, renewable energy and pollution treatment, and futuristic research for sustainable development. The presented idea is hoped to inspire researchers and innovation developers to overcome challenge issues and build up sustained innovation. I think there is a good word now, sustained innovation. Okay, I think that is all. our session. And before I close this section, please, we need to have a photo section. So please turn on your camera. Okay. I will take a first screen. There are 4 screens here in my laptop. Okay, 1, 2, 3. Next screen. 1, 2, 3. Okay. Next screen. 1, 2, 3. This one is last screen. 1, 2, 3. Okay. You can turn off your camera back or keep on the camera. Okay, I will give a thank you for our presenter, Professor Barton and Professor Trisab Santorn, that deliver the presentation. And I think I will give it back this session to the MC. Okay, thank you very much.
Thank you very much for the Excellencies, keynote speakers for an interesting presentation. Thank you, the moderator, for leading the main session nicely. Ladies and gentlemen, after this, we will have a break. Then we will continue the agenda with a parallel session. The parallel session that will be held at 12:15. But please stand by 15 minutes before that at 12 o'clock. So thank you and have a good rest.